have here a Macintosh SE30. This unit was given to me by a former coworker of mine several years ago. When I got it, it was already exhibiting issues with sound, but otherwise was fully functional. Over the years, it's sat in the back of my office, occasionally turned on for fun, and when I recently changed jobs, I put it into the bag that I got it with, and haven't done much with it since. I never got around to solving the issues with sound. Occasionally the CRT does things, and as far as I can tell, the floppy drive never worked. I know I just said the floppy drive doesn't work, but while filming, I discovered that it tries. It still fails to initialize the floppy though. I think I've got what I need, so I'm ready to dig into this machine to find out what upgrades were done to it, replace some aging components, and figure out what this label means. This thing is absolutely cool, and I hope to breathe new life into it. In the late 1970s, an employee at Apple named Jeff Raskin envisioned an easy-to-use, low-cost computer for the everyman. Developed at the same time as the Apple Lisa, a higher-end business-oriented line of computers that ultimately failed, the Macintosh and Lisa were both influenced by the revolutionary work done at Xerox and incorporated software that heavily relied on a GUI, a feat that wasn't possible on consumer computers without the introduction of the Motorola 68K microprocessor in 1979. In fact, the Macintosh was originally intended to be a text-based replacement of the Apple II, as an 8-bit computer incorporating the Motorola 6809E microprocessor. But a member of the team, Bud Tribble, wanted to run Lisa-style graphical programs, and Burrell Smith managed to design a board that combined the low production cost of the Apple II with the power of the 68K from the Lisa. With the launch of the Macintosh in 1984, Apple revolutionized home computing. While more expensive than the most popular systems at the time, it beat nearly everyone else to market with an easy-to-use graphical computer that was within reach for many consumers. The following year saw attempts from Microsoft, Atari, and Commodore to capitalize on the idea, but none were able to truly hold a flame up to Apple. The shortcomings of the first Macintosh, the lack of memory and inability to upgrade it, were addressed in the Macintosh 512K and further improved in the Macintosh Plus, one of the longest lived models Apple produced unchanged, nearly 5 years. In 1989, Apple expanded the Macintosh line, including a new desktop model, the Macintosh 2. This used the updated Motorola 68020 processor, added an internal hard drive, brought color to the lineup, and allowed for increased expandability using the new bus expansion slots, like IBM PCs at the time. Additionally, Apple updated the compact model and released the SE. However, this cheaper model still sported the same 9-inch monochrome monitor of the previous compact Macs. With the introduction of the Motorola 68030 in 1988, Apple introduced the Macintosh 2X, and later in 1989, the 2CX, a more compact version of the 2X. Both models sported the same 16 MHz CPU, at minimum 1 MB of RAM, and an increased density 1.44 MB floppy drive called the SuperDrive. Like the Macintosh 2X and 2CX, the Macintosh SE30 was a processor upgrade of the previous SE model. The SE30 had the same 16 MHz 68030 microprocessor, 1 MB of RAM, 1.44 MB SuperDrive, and a 40 or 80 MB hard drive like the 2X and 2CX. The SE30 could be expanded up to a whopping 128 MB of RAM, which was a significant amount at the time. That is, theoretically. I say theoretically because the original 68K processors, while 32-bit, only had 24 physical address lines, and thus limited the amount of memory that these systems could have, which, at the time, was more than sufficient. Additionally, engineers made good use of the unused byte in each memory address, and placed flags in the high 8 bits of each 32-bit pointer. This became a problem with the 68020, which had a full complement of 32 physical address lines. This was addressed by forcing the machine to run in 24-bit mode, which still limited memory to 8 MB. Memory support was later expanded in System 7, with a free software patch that reinitialized the memory manager in 32-bit mode for these newer processors. However, with the introduction of System 7.6 in 1997, rebranded to macOS, a 32-bit clean system was required. Despite being able to physically address 32 bits, older ROMs were still 24-bit. These systems could be made 32-bit clean by swapping in a ROM from a clean system, while third-party ROM kits were also available. My SE30 has been upgraded to 8 MB, but still retains the 24-bit dirty ROM. The hard drive and floppy are original to the unit. In fact, it seems like the machine hasn't had a ton of modifications done to it over the last 30 years, except for this video adapter plugged in between the logic board and analog board. Before diving too deeply into the treasures inside this SE30, we must first crack it open. Opening this machine is straightforward. Using a long-shafted T15 screwdriver, we can remove the 4 screws holding the back of the machine's case into the front, and simply slide the case off. In here, we'll find what makes up the bulk of the machine, the CRT. I don't plan on removing the analog board in this video, even though there's a good chance that the capacitors on it are starting to fail, but I'll still discharge the CRT and unplug it from the flyback transformer for safety, since I'll be working near the CRT. With the CRT discharged, I can begin pulling connections from the analog board, logic board, and drives so that I have room to work and can remove components. While disconnecting the ground from the board connected to the end of the CRT, I managed to strip the threads in the hole that the screw holding the CRT went into. We'll address this in a moment. For now, I'm going to carefully remove the board connected to the back of the CRT. The next part I'm removing is related to this label that's on the back of the case. It's a PowerR video adapter for the SE30. This little accessory allowed the SE30 to mirror video to an external video device, such as an LCD or projector, though it seems to be outputting some kind of non-standard TTL voltage level signal. I'll be removing the video adapter from the machine completely. It may return for a future project, hacking it into some kind of capture card, but for now it's not very useful. Once everything is disconnected from the logic board, we can remove it. It simply slides up, and once the tabbed edges line up with the gaps in the chassis holding in the logic board, it swings out. Be sure to unplug the speaker since it's now accessible. Look at that beauty. Finally, I want to remove the drives from the machine. I need to do some refurbishment on the floppy, and while testing, I won't need these in the machine. The screws holding the entire assembly are accessible from the bottom with the logic board removed. Mixing up some 2-part epoxy, I first attempted a trick to recreate the threads so that I'm not permanently adhering the screw to the front panel. First thing to do is to toss some epoxy into the hole. Next, to ensure the screw comes out, I coat it in petroleum jelly. Any light lubricant should work here. Once the epoxy sets, I remove the screw. Unfortunately, it seems that this method was not good enough, and even though I gave it a good few days to cure, the threads created simply stripped. I loosened the heavy wire bracket around the CRT, filled the hole with epoxy again, and then affixed the ground wire and bracket permanently. Once the epoxy fully cured, I tightened the wire bracket back in place, and the fix seemed to hold. This will be a future problem to solve down the road. Before attacking the logic board, I first need to remove the ROM and RAM sims. These come out by bending out the side tabs and leaning the module back. I find that for the RAM, it's easiest to start in the back and move forward. Reinstalling the module should be done front to back. Next, I pull the PRAM battery. I'm looking that this battery hasn't decided to leak on me, especially considering this is the original battery from 1989. Inspecting the board, overall, it looked to be in good condition. The worst damage I could see at first glance is these set of traces around the C6 capacitor. Regardless, before addressing this, I need to remove the capacitors, and given the age of the machine, I'll be removing all of them. Once I've removed all the capacitors, I needed to test the traces on the board. I only found one trace that was damaged from capacitor fluid, despite all of these looking damaged. I removed the coating on the trace, coated it in solder, and added a small wire to complete the trace. Once I was confident that it was attached, I checked continuity, and then checked another part of the board that might have trace damage. Once everything seemingly checked out, I soldered the new capacitors in. After completing the repair, I gave the board an isopropyl bath to dissolve any flux residue. Soaking it for 15 minutes or so, I dry off the board and do some manual scrubbing to get rid of anything that didn't dissolve. Now that the repairs are done, I reassembled the SE30 and did my first test. I had some mixed feelings. I got the boot tone that I wanted, and I was initially happy. Then I saw the signature zebra pattern of a condition called CMA-CMAC. I was disheartened. I tested my trace repairs, ensured that the capacitors were properly soldered onto the pads, and even replaced some of the solid caps with electrolytics that I had so that there was no question that any traces were shorted by the wider leads of the solid capacitors. And yet, no luck. At this point, frustrated with how this was going after an hour of work and initial troubleshooting off camera, I gave up and went to get a shot of tequila at the local Mexican restaurant. Regrouping my thoughts and remembering that the machine was starting to show weird failures before working on it, I formulated a new plan. Before going any further with logic board troubleshooting, I'm going to address the analog board and power supply. I started hearing nasty noises coming from that area, and the SE30 exhibited different failures depending on how many times I boot it and how warm it is. Once I have eliminated the potential issues with the analog board and the power supply, I'll readdress troubleshooting the logic board. Not every project is always successful at first, and I think that's part of the journey, both in the projects I've made before this channel and the ones I'm sharing with you guys. I don't want to hide my failures. That would be severely disingenuous. I'll circle back around to this project in part 2 later down the line, once I've got additional components in and do a bit more research into the matter at hand. For now, I'm going to move on to other projects since this one has come to a good stopping point. In the next few videos, I may cover a project I've been putting off for a while. Something geared more towards the electronics design and keep bashing into things that I like to do, in addition to these classic machines. Check out my Twitter for teasers as I work on them, and join my Discord as well. Links are in the description. Either way, despite my failure, thank you for watching.